Hello students, today we are going to learn on continuation of circuit breakers, the vacuum circuit breaker. Last class we have seen oil circuit breakers. One is bulk oil circuit breaker and minimum oil circuit breaker. Next, another family of the circuit breaker is the vacuum circuit breaker. It is a very simple and variety of vacuum circuit breaker. In this case, arc quenching is a different, and media used to quench the arc is also there is no media to quench it. Then how to quench the arc and what is its significance? Let us see one by one in this class. Now this is a session regarding to diploma 5th semester EE 504A switchgear and protection subject and chapter 2 switchgear and protection. In that, circuit breakers and reactors. Let us learn one by one in details. Now let us see what are the objects today we are going to cover. On completion of this topic, you would be able to know one, the introduction of breakers, salient points of VCBs, vacuum circuit breaker, construction of vacuum circuit breaker and operation of vacuum circuit breaker, and merits and demerits of vacuum circuit breaker, and lastly we are going to learn where we are going to use these vacuum circuit breakers, that is the application of vacuum circuit breakers. Let us see these breakers in details with diagrams. At the same time, we are going to observe this operation in a real field. So that purpose we are going to see few videos also. Let us learn these things very clearly and slowly. Now we can see our substation. The substation consists of different switching operators, controlling operators and functioning operators. By keeping these all operators in a systematic way, then we are going to supply the electrical energy in a quality way to consumers on reliable conditions. At the same time, if even we are going to plant in such a manner, sometimes there is a unpredicted the faults may be occurred, like the lightning discharge, sudden opening and closing up our breakers. Then there is a possible to abnormal characteristics changes in our electrical energy, sometimes due to the high voltage, due to the high currents, due to the short circuit, and insulation of the all systems may be failures and collapse the total system. Hence we have to ensure all equipment should be perfectly controlled, perfectly insulated, perfectly isolated, and at the same time all non-current carrying metals should be at the potential. In that way, we are going to learn the switchgear and protective equipments, the circuit breakers. As you know that circuit breaker can be operated under any condition, normal condition and abnormal conditions. Now we can once again see it, the classification of circuit breakers. The breakers are classified based on the different factors. One is the location, another is the voltage factor, another is the medium which is used to nullify the arc in case of arc arised in the breaker. Now based on the location, so it is classified into the indoor breakers and outdoor breakers. This is based on its capacity. less than 36 kV we can use indoor, and if more than that voltage we can use an outdoor circuit breakers. Based on the voltage, as we know that the voltage is the low voltage, medium voltage, high voltage, extra high voltage and ultra high voltages. That is based on these voltages. As we know that the LT voltage less than 1000 volts, and medium voltages you can see the breaker which is used greater than the 1 kV to and 52 kV voltage. In between we can use the medium voltage breakers. For high voltages, the greater than the 52 kV to the 220 kV voltage, that is, it may be one in case of 130 kV substation, 66 kV substation we can use. Those are known as the high voltage breakers. Behind this high voltage breakers, that may be 400 kV or 765 kV, we can use the extra high voltage breakers. And beyond this, furthermore, where the greater than the 765 kV, we can use the ultra high voltage breakers. And based on the medium, which type of the medium you are going to use for nullify the arc. So whether you are going to use the oil, or whether you are going to use the air blast, whether you are going to the gas, that is the sulfur hexafluoride, or if you are not using any type of the gas, or removing the air from the chamber, that is known as the vacuum circuit breaker. These breakers also designed based on its media as well as the voltages. Simple, it has the interrupting chamber and supporting chambers. If the voltage increases, then there is a possible to, it is a modular design, that may be interrupting chambers connected in series. Whereas, already we have seen in bulk array circuit breakers and minimum array circuit breakers, its applications, advantages, disadvantages, working principle, construction, all things we have seen. Now in the series of breakers, now we are going to see the variety of the breaker, that is the vacuum circuit breaker. Here the vacuum, that is the no air presence. So how we are going to use this vacuum circuit breaker to operate in our power system, the distribution system. You might observe this type of the breakers in 33/11 kV substations nearby the mandal headquarters, nearby mandals. Now let us see. Now this is a 133 kV by 11 kV substation. It's a vacuum circuit breaker. You can see. So this breaker, what is the? It is a breaker. You can see this is the chamber. This is a supporting chamber. So where we are going to nullify the arc in this only. So that is the thing. Now, this breaker can be used in power system or distribution system. Sometimes we can use these type of the breakers nowadays in industry also, in big industry. At the same time, this type of the breaker also we can find in railway, the railway electric locomotive. How you find the pantograph is connected to the 26 kV voltage single line. So over which it is connected to the one VCB. You can see here the VCB. This is the train top, and here you are going to see this is a breaker VCB, and this is a VCB, the cylinder, and if it is opened, so you are going to see this inside the parts. These are high voltage. So in railways we are going to use the VCB for 26 kV single line, whereas in 33 kV substation we are going to use this one, so 33/11 kV substation as an incoming 33 kV as well as the 11 kV feeders also we are going to use. So what is the benefit of this vacuum circuit breaker? Means the vacuum circuit breaker can be operated nearly 10,000 times on off conditions. Even then there is no maintenance, easy to operate. So we can see later about this one. So these are the vacuum circuit breaker we are going to learn in this session. I think you have some idea. So how this vacuum circuit breaker used in substations. Now before this one, So you should know what our switchgear, the intelligent circuit breakers. Once again, so this is the one system adapted in our distribution system, in power system, to protect the lines, live lines. How it will works? So under normal condition, you can see once again at a glance, I am going to explain this relay and circuit breaker combination, how we are going to protect our system from the fault conditions. Any unwanted problems occurred in the system. Now you know this all things, but so as a basic thing you should know the operation of our circuit breakers. So here under normal condition you can see, so what is happening here? Normal condition, the whatever the current is coming and it's entering to the, is going to the circuit breaker and entering to the load, after load is going to the and next place. During this period, our intelligent fellows, one is the PT, potential transformer, and the current transformer, both are observing the line continuously with binoculars. So what is happening? If under normal condition, whatever the current flowing through the line, it has some electrical properties, electrical characteristics. Under normal condition, these electrical characteristics are within limit, no violation of predetermined value. Then if something happen, these electrical characteristics changes. Just like under healthy condition for a human body, what is this heartbeat, what is this cholesterol, what is this BP and temperature. Similarly, it has some attributes. If subjected to some fever, for example, in case of the corona effect nowadays, its characters, these all values are changes. It's what is happening? Oxygen value changes, the BP value changes, cholesterol value changes, and so on, increasing these values are changes. Then we are said this person infected with the coronavirus. Similarly, our system also intelligently monitored by intelligent fellows, CT, PT. These values are given to our relay system. The relay system will analysis takes place continuously and compare the predetermined values. And if these values are violates with predetermined values, then automatically that signal will gives to the breaker, where the mechanical breaker simple operates. It should be closed or it should be open at any condition. So during this process, so it will analyze the system characteristics. Now in this case, we assumed there is no fault current, there is no overload occurred. Then so whatever the current comes in the system, it is a normal current within the predetermined value. Then whatever the CT second ratio current flowing, so flowing through the CT coil, trip coil, is unable to close these trip contacts. Then mechanism will not operate. Now second case, if I am going to create one fault here, earth fault, then what is happening? The current which is feeding to the fault current is enormous as comparing to the previous value. Previously, let us assume it may be 50 amperes. Now the current increased to 500 amperes. This increased short circuit current proportionate current flowing through the CT, and the CT develops a high magnetic flux that will try to pull upwards these trip contacts. Once trip contact closes, then the battery will come into picture. Then whatever the energy, electrical energy given to the mechanism, the mechanism will operate to open the circuit breaker. Once the circuit breaker open, so the arc will comes. As we know that when the two contacts are closed condition through a metallic part, then current easily flows. When the two contacts are opened, then what is happening? In between there is no conducting path, good conducting path. there is a media, it may be air, it may be oil, it may be SF gas, it may be anything, through which these electrons which is try to flow. That means whenever this charge particles flows through the air, that is known as the arc will develops. This arc having the high temperature 5000 degree kelvins. This high temperature melts the tips of the two male and female contacts. This is a undesirable things. Then what to do? We have to as possible as we have to nullify the arc. So that purpose we have different technical methods. The high resistance method, a low resistance method already we have seen. So based on these theories we are going to quench here. Now in this case, now today topic, the previous case we have seen in circuit breaker, oil as a dielectric media. So it is used to quench the arc. Now in this case we are not using any type of the media. Simply whatever the air inside the cylinder, that is evacuated. So we taken out. So what is happening? It's a nearly, it is vacuum is created 10 to the power of minus 5 to minus 7 torr. That much of the vacuum is created inside. If there is no air, what is happening? So there is no formation of arc. As we know that the candle should be a flame with the help of the basic fuel materials. One is the basic things required, 3 items is required for any arc to sustain for that time. For flame of any candle, what is required? We require the fuel is required. Second one is we require the oxygen is required, and third one is required the required temperature. The temperature, oxygen and fuel should be required for continuation of flame. So in this principle, so inside whatever the air inside the chamber is evacuated, no air presence. Without air there is no oxygen. Without oxygen the fuel is present. Here is not providing any fuel. So this contacts terminals act as a fuels, but there is no oxygen. Then automatically, so it weakens the arc for next few microseconds. Then it will automatically quench this arc when it comes to the zero crossing period. So that can learn in clearly with the help of diagrams. This is the basic idea of vacuum circuit breaker. So here the basic thing you already know. So under normal condition the current is flowing through this one and load and everything is working functions perfectly. Now what happened if I create the fault one place, then what is happening? The current is flowing through the battery and breaker is opened, the arc is occurred in between the moving contact and fixed contact. That is nullified by using a different media. In previous case we used the oil, transformer oil, it decomposes and decomposes and dissociation takes place. It produces the different of the gas particles and the hydrogen particles, nearly 80% remaining ethane, methylene, acetyl, different gases. So due to the hydrogen bubbles, hydrogen gas, it is a cooling media and it cools and lengthens the arc and nullifies the arc at zero crossing period. So that is the principle in all circuit breakers. Now let us see in vacuum circuit breakers. Here there is no media, and how we are going to nullify the arc is generated during the separation of contacts. As we know that, so the circuit should be closed and open. During this process the arc will comes. Then arc, how we are going to quench it. This is the basic idea. Here we are going to learn. Now let us see this one. Now you can see the internal parts of a vacuum circuit breaker. Each part, what is the purpose? How we are going to control? This can be see with the help of the figures. Now you can see here what is the definition of vacuum circuit breaker. This is the main, the arc extinction chamber. So everything is going on inside only. We have to learn it. So what is it? We will learn first. Let us first definition of vacuum circuit breaker. The vacuum circuit breaker, it is a kind of circuit breaker where the arc quenching takes place in a vacuum medium. Definition: the arc quench takes place inside a vacuum medium. The operation of switching, open and closing of current carrying contacts and interrelated arc interruptions takes place in a vacuum chamber in the breaker, which is called a vacuum interrupter. You can say this is a vacuum interrupter. Everything is going here. It is a perfect sealed material. Now, so what it consists? Let us see. Now, here two types of the breakers generally consist. What is that one? Before entering into the construction point, so let us see some salient points of this one. Now, here, so you can see the figure. You can easily understand the value. Here you can see it. So this is a breaker used in industries, indoor type, where the voltage less than 38 kV. We can use this type of the breakers in indoor type, in industry, in factories. For outdoor purpose, we are going to use this type of the breakers. You can observe this type of the breakers in substations. Now, so here it has a arc interrupter, it has also arc interrupter. The working principle is the same, but so based on the insulation material used is different. Now, you can see what are the salient points. In a vacuum circuit breaker, the vacuum of the order of 10 to the power of -5 to 10 to the power of -7 torr is used as an arc quenching medium. Already we know that. So, very less 10 to the power of -5 to 10 to the power of -7 torr. That is the vacuum creator. Basically, the vacuum is a pressure below the atmospheric pressure where no gas is present inside the chamber. These breakers have the highest insulating strength than any other medium which is used in oil, weather, air. This is a high dielectric strength. The vacuum circuit breaker does the interruption of the current at the first current 0 in case of AC cycle. So, as we know that our frequency is 50 Hz, it has 50 positive cycles and 50 negative cycles. Whenever the short circuit comes and when it reaches to the 0 crossing period, then automatically it will nullifies, it will quenches. It means it interrupts the current in the off cycle itself only. The vacuum circuit breakers does the interruption of current at first current 0. So, that is the things you should know. That means that interrupts the current in the off cycle itself. And it is designed for the medium voltages. You can see some medium voltages from 3.3 kV to and 33 kV general applications from industry to and substations. General capacitor. The arc burns in metal vapor when the contacts are disconnected. In this case, arc is developed from the contact material. Generally, these contact materials are of the copper and bismuth, copper and chromium. These metals, when subjected to the high current, so it converted the surface material converted to the vapor, through which the electrons will try to flow, then arc will comes. That we'll see later. At a high voltage, the rate of dielectric strength recovery is very high in this case of vacuum circuit breakers. So, due to the vacuum, the arc extinction is very fast as compared to the other circuit breakers. The contacts usually loses its metals gradually due to the formation of metal vapors. The erosion of the contacts is going on decreasing because this metal is microscopic. So, it is it is converted to the vapor and so deteriorates its surfaces. That is one thing. Let us see later one by one. Now, you can see the industrial purpose, which type of the breakers is generally used. What is inside here? What is inside? So, as we seen, so vacuum interrupter. What is inside the vacuum interrupter? So, how we are going to use this vacuum interrupter in industries? Let us see the vacuum interrupter here. This is the vacuum interrupter, and if you remove this vacuum interrupter outside, then you can see the clearly the shape of this one. So, here if you remove this glass or ceramic material, then inside, if you are seeing inside, then you can observe these are the inside the interrupter. And so, here interrupter consists of male and female contacts, mainly parts. How these are made? What are the different shapes? So, you can see here. So, this is one interrupter. If you are removing this, the fixed and moving electrode or contacts, then these are the different shapes. What are the shapes here? So, you can see it. First, the solid butt design. One is you can see this is one moving, the fixed rod, this is a moving rod. So, shape is can see the solid one. So, it is known as a solid butt design. And sometimes we can use another type is the spiral TMF design. You can see the area, it is a changes some design itself. Now, so another type is the axial magnetic field design. So, you can see it. What is the shape? And the last one is generally used and famous is the horseshoe design. You can see it. So, these are the different types of the male and female. Otherwise, you can have fixed and moving contacts inside the interrupter chamber, where these are placed inside the vacuum. So, these things. So, what we have seen? So, we have seen these rods, male and female, the contacts areas are eroding, evaporating in these materials. Even then, so we can use this type of the breakers nearly 10,000 operations. So, you can see the what is the maintenance less of this system. You can see for a practical the 33 kV vacuum interrupter, what is inside? You can see it. So, this is the one 33 kV vacuum interrupter. Similar, same it has some parts. These parts will learn in details one by one. Now, here, so before, okay, let us see the parts. After that, we will see the how this vacuum circuit breaker used in less than 38 kV, used in industries. Beyond that, how we are going to use in our substations. Both places we can use it. Let us see first what are the parts of VCB. the VCB, this is a one interrupter. If you open it, so what is happening? This is a rod. So you can see it, what are the parts. So similarly, here you can see it. First, the total part. What is that one? So insulating envelope. It is made up of glass, or sometimes we can use the insulating material. You can see that is sometimes we can use a ceramic material also. Glass or ceramic material generally used. So you can see here outside here the ceramic material. Sometimes we can use the glass also. You can see that one also. And after that, what is it consist? First is the insulating envelope, overall the envelope. After that, you can see it. What is that one? The vapor condensation seals. So what is the vapor condensation seal here? So here the vapor condensation seal is nothing but, so here whatever the vapor inside developed, that is avoid to come outside of this one. So it is also made up of stainless steel. Sometimes we can see this is the sputter. And next one is the end shield is supporting this sputter. Next is the shield support flanges. So it is it will protect and mechanical vibrations also. So here we can use it. Next is a moving contact. Here the moving contact is fixed with some moving arrangement. Here you can see here similar to you can see here, not only this moving contact, so it has some arrangement here. So what is that arrangement? You can see it is a bellows. So bellows is a flexible stainless steel conducting material. It can easily movable. It has some mechanism. And next it's shield also. The bellows shield. The bellows shield will move according to the moving contact. And coming to the another one is the fixed contact. So fixed contact is fixed to the top, and moving contact which is moving up and down with help of bellows and the shield. And after that, so we are going to create inside the vacuum nearly 10 to the power of -5 to 10 to the power of -7 torr, the mmHg. So these are some parts of a real-time vacuum circuit breaker interrupter. I think you can analyze it. Here, what is this one? This is a fixed rod. Now this is a fixed rod, and this is ceramic material or glass. This is one, and here is a sputter. So you can see the inside. You can see one metallic stainless steel. Here is removed, I think. Now this is the moving rod. Then here is the bellows shield. Now bottom the stainless steel bellows, and so inside they are going to create the vacuum here. And this is the end coupling. This is the end coupling. So these are the parts. I think you have some idea on the parts of a VCB. Now after that, so we are going to learn one by one in the construction of a VCB. Now we have seen the parts. Now each part, what is the purpose? How it is the construction? This is the interrupter. The overall how it is the construction of the VCB. So before that, so we will see this is a interrupter shield generally used in high voltages and low voltages in substations as well as in industry. In industry level, so you can see one real time working of animation, how this is the breaker can be used to interrupt and what is its a mechanism. You can see it. You can see it. The main parts of the VCB. This is bus bars, fully insulated bus bars. Current rating you can see 4000 amperes. Individual the panels. The vacuum circuit breaker and automatic switch arrangements. Now we can see its constructions. The circuit, earth switch also provided with combination this one. Cable terminals. Voltage transformers. Low voltage compartment. The integral arc chambers. Now you can see how the circuit breaker insertion takes place, how its mechanism is going to assemble the system. Everything is systematic, everything is an interlocked system. You can see here. Input and output setters, that one. The shutter, padlock, and everything is interlock. Connecting rods. So this is one example of VCB generally used in our industrial fields. Similarly, different companies and different ranges can be used and protection of the system. Now let us see. Let us coming to our topic. Now we have seen the interrupted chamber with mechanism, with interlocking system. Everything is going to protect our electrical equipments and circuits as well as the operators also. Now if you see the what are the construction of this vacuum circuit breaker, you can see it. Here you can observe what is it. So this is a line diagram. This is a real figure. This is a one diagram. You can see same parts we have seen here, and it has an outer envelope which is made up of glass joined with end caps. Here these are the two glass white. You can see that this is the last one, this one glass. Previously was in the white color. The glass shield is used to examine the breaker after operation. If the color becomes milky white, then it indicates that the breaker is losing its vacuum after some periods. Based on this color, we have to remove the interrupting chamber. The main arcing process is done in between the two contacts here only, fixed and moving contacts. This is a fixed contact and this is a moving contact. That purpose we are going to use some below the stainless steel flexible conductor. The moving contact is connected with metallic bellows which are made up of stainless steel material. These bellows are used to move the moving member up and down, and a spring mechanism is connected with the bellow to operate them in a systematic way whenever it is required. Here you can see the another part here, the sputter. You can see this is a one sputter. Is made up of same stainless steel material, is present to prevent the metal vapor from reaching outer envelopes. So just it's a avoid, prevent the exposing of the escaping of the metallic vapor inside during the arcing process. The ceramic envelope is also present to insulate the total chamber. Ceramic material, you can see here, this is ceramic material. These are the some parts of this one constructions. So now see it, simple parts, only it is a fixed contact, moving contacts. The mobile conductor is having help of bellows and a supporting bellow, and what is the required. So everything is end shields, and the body is made of the glass or ceramic material, and it has some insulating envelope. It is also made up of ceramic or glass, and shield support flange, bellow, it is made up of the stainless steel, and the bellow shield, and vapor condensation shield, we can say that is also sputter. It is also made up of the stainless steel. Only few things present in a vacuum circuit breaker. What is the purpose? Already we have seen. Now after seeing this one, let us see the working principle of vacuum circuit breaker. Now you can see these are the salient points construction. Now you can see here, so this is a working principle. How the breaker is working here. Now so this is the breaker, you can see here, clearly you can observe it. This is the total breaker operation. In that one it is a arc quenching chamber, that is this one, and if you are seeing in between what is happened during the arc quenching period, this one. Let us see one by one. Under normal condition and under abnormal condition, what is going on inside this one, you can see. Initially the fixed contact and moving contact, both are contact to each other, just like good friends. The current flowing through them smoothly without any making or heat energy under normal condition. Whatever the current is coming, simply, so here current is coming, it is going simply. So no problem in between two. Both are intact each other. But whenever the fault occurred in the system due to the any fault, symmetrical fault or unsymmetrical faults, the moving contact received the signal from our intelligent fellow. Who is that one? Is the relay system. Relay will take the decision based on the CT and PT, current transformer and potential transformer. Then whenever receive the signal from the relay system, the moving contact try to move away from the fixed contact. Now both friends are very closely. Now we are forcibly separating to each other. One friends we are separating. Now what is happening? Already you know. Now after disconnecting the contacts, the last point of current will be the contact surface, which results in high current density at these points. Because this process takes place whenever the current is an enormous current, that is under short circuit condition. The current is very very high, and whatever the current is flowing through the two contacts, suddenly we are opening. At that condition, the contact area reduces, but current density increases. When current density increases at these points, due to which the resistive heating takes place. The heaters we know, whenever the current passing through this material, resistive materials, because these materials are having the small amount of the resistance, through which this short circuit heavy density current flowing through this one, and heat will develops. So it is known as a resistive heating takes place. Due to the excessive heating, the metal ions starts vaporizing from the contact surface. So the current once it is moving this direction, and whatever the contacts here, the simply due to the high temperature, the vaporizing takes place and it converts the solid form to the gaseous form. The contact surface has a large number of microscopic projections, two contacts. So we will see the contacts also, the shape of the different contacts also. So these two contacts has a large number of microscopic projections. So these are the play a vital role. The arc is generated due to the vaporization of metal vapors from the contact surface. Whenever this contact generating the metal vapors, through which this short circuit current try to flows. In previous cases, what will happen? When the current is passing through the conductor, simply we know as a current. Whenever the charge particles flowing through a conductor, we can say this is a current. Whenever the charge particles flow through a air or some medium, then we can say it is an arc. Now the medium is the metal vapors, through which the short circuit current will try to flow. Now what has happened on the contact surface? Now the arc interruption in vacuum interrupter is different from the types of other breakers as previously we have seen. So whenever the arc comes, at that case the media will play a role. It generates hydrogen bubbles, something. Now here there is no any media. Now the contact metals converted to the top surface of the metals generates the metal vapors, through which this short circuit current is try to flow charge particles. Then arc will develops. So here what is happening? So it is a something is different from the previous one. Now in this case, the separation of contacts causes the release of vapor which is filled in the contact surface. The vapor consists of the highly positive ions liberated from contact materials. You can see the figure here also. The vapor density depend upon the current in the arc. If the current arc is more, the density of the liberation is also more. What happen if the current is more? Suppose if the current is less, when the current to be interrupted is very small in a vacuum, the arc has several parallel paths. Not only it will flow, it is a parallel paths. Small in case of current is a low current case. So as we know that, so the vapor density depends on the current in the arc. If the current is less, then what is happening? When the current to be interrupted is very small in a vacuum, the arc has a several parallel paths from fixed contact to moving contacts. The total current is divided into many parallel arcs which repel each other because it has some magnetic property, repel each other and spread over the contact surface. Totally contact surface it occupies. This is called a diffused arc which can be interrupted very easily. Once again, so what is happening? When the arc current is very low, then the arc current which flows in a parallel paths, several parallel paths. The total current is divided into many parallel arcs which repel each other and spread over the contact surface. This is called diffused arc which can be interrupted very easily in this case. Suppose if the arc current is very high, then what happened inside the chamber? At high value of current, the arc gets concentrated in a small region. Then it concentrated. It's not flowing the parallel paths. It causes a rapid vaporization of the contact surfaces. Due to the high current, the vaporization of the metal parts increases. The interruption of the arc is possible if the arc remains in the diffused state now. If it is quickly removed from the contact surface, the arc will be restrike once again. So we should wait. So these are the things going to done. That means when the current is less, the arc split into the parallel paths. When the current is very high, and it will develops a more metal vapor. These are the things. Now what is happening? After separation of two contacts, long period, its distance is more. When the current decreases automatically, when the current decreases, the rate of vapor release decreases, and after current zero, the medium also decreases. The medium also regains its dielectric strength if the vapor density is reduced. That means if dielectric strength automatically increases if the vapor pressure decreases. That is the thing. Now what is happening? Once dielectric strength inside the two contacts increases, then what happened? When this automatically it will unable to maintain the arc. It will nullify next when it reaches to the zero crossing period in a cycle. And when this arcing contacts reaches a first zero at off cycle, the dielectric strength of the vacuum rapidly build up and interrupts the current at first off cycle. So this can be seen with the figure. Okay, let us see. Now you can see here, when it comes to the zero crossing period, when this arcing current reaches its first zero at off cycle, the dielectric strength of the vacuum rapidly builds up and interrupts the current at first off cycle. Now, what is happening at that condition? The arc will not restrike because of heavy high insulating strength of vacuum buildup regain. That means the dielectric strength, the buildup between the two contacts. So, these are the basic principle. So, let us see here the arc extinction in vacuum. So, what is happened? What is the process? So, let us see the one animation also. You can get the some idea. When these two contacts, so okay, you can see the one animation, then you can get the some idea. At the same time, you have seen the vapor density also depend upon the surface of materials, two contacts. Here you can see the side figure. Before that one, the arc extension in vacuum breakers is greatly influenced by the materials. What are the materials? Male and female are fixed and moving contacts were manufactured. Generally, these are manufactured by alloy materials. Some copper and